Hello friends, today we are going to see the properties of metal, so that is important mechanical properties. So first we are going to see the elasticity. So it is a property of materials deformed under the load and it's enabled to regain its original dimension when the load is removed. So if the body regains completely its original shape, it is called perfectly elastic body. So the elastic limit marks the partial breakdown of the elasticity beyond which the removal of load result in the degree of permanent deformation. So the steel, aluminum, copper may be considered as the perfectly elastic material within the constraint limit. So next one is plasticity. So the characteristics of the material by which it undergoes inelastic strain beyond those the elastic limit is known plasticity. So the property of particularly useful the operation of pressing and fogging. So when the large deformation occurs in the ductile material loaded in the plastic region, the material is said to be undergo the plastic flow. So the material can't regain its original dimension because of the permanent deformation. So next one is ductility. So it is a property which permits the material drawn out longitudinally to the reduce the section, so under the action of tensile force. So the one part of so the longitudinally the material is extended and likewise in other side it's get decreased. So the ductile material must possess a high degree of plasticity and strength. So ductile material have low degree of elasticity, that is useful in wire drawing. Okay, so the next one is brittleness. It's a lack of ductility. The brittleness implies that cannot drawn by tensile or smaller section. So the brittle material can failure under the load without significant deformation. So we can take it as the concrete or glass. These are all called brittle materials. So they can't deform in any places. So next one is malleability. So this is a property of material which permits the material in extended in all directions. So if the material is only allows to extend in the longitudinal section, so that is called ductility. So in malleability it extended in all direction without rupture. So the malleable material possesses high degree of plasticity but not necessarily great strength. So then next one is we go for toughness. So it is a property of material to enable the absorb energy without fracture. So it is desirable in material which is subjected to cyclic or shock loading. So it is represented by the area under stress strain curve for material up to the fracture. So the bend test is commonly used for comparative test of toughness. So the next one is hardness. It is the ability of material to resist indentation or surface abrasion. So is a surface abrasion is very much important for construction materials. So then also in any material the abrasion is should be the minimum. So we can go for a Brittle test for find out the hardness. So the Brittle hardness number, the formula is P divided by pi d divided by 2 into d minus root of d square minus small d square. So here P is equal to standard load and d is equal to dimension of ball and small d is equal to diameter of indent. So the indent is ball indenter or diamond indenter. Okay, so next is strength. It is a property enable the material can resist the under fracture under the load. So this is most important property for design point of view. The load required to cause the fracture divided by the area of the test is termed as ultimate strength. Okay, so now next we go for stress. So it is a resistance offered by the body to deformation. So the normal stress is called the load divided by the area. So the load divided by original area. So the actual true stress equal to load divided by changed actual area. So then strain, so the deformation per unit length in the direction of deformation is known as strain. So this come under longitudinal strain and lateral strain. So the strain equal to del L, change in length divided by original length. So the strain is dimensionless quantity but stress is equal to kilonewton per meter square. So the load is measured by kilonewton and the area is meter square, so the kilonewton per meter square. In material engineering, so the stress strain curve of any material is very important because it is very much useful for find out the material's elastic limit and ultimate strength and elastic region, then strain hardening and fracture point. So everything we can get from the stress strain curve. So stress strain curve is drawn by using in x-axis is a strain percentage and y-axis stress percentage. So we can we can plot the graph in stress and strain. We can get the ultimate point, the ultimate load and elastic limit, and everything we can get that. So these are all the things is very important for material science, in material engineering, in the mechanical properties of any material. Again we will see in next video. Thank you.